Right, we're back at it. We're back at it with proving things. I'm going to try to prove some stuff. We've got two cursors. We got two cursors. Everything's going wrong. I've cut off the church bells. Hello, Happy Nora. I'm a little warm. How about you? And I'm not sick anymore. Actually, I only just realized I'm not sick anymore. So that's good. Apparently something's going around. That's what they're saying. Okay. Yeah, it's warm. What's the temperature where you are without doxing yourself? I'll add or subtract a number from mine. I've got the fan on. Terrible streaming game. It's allegedly only 25 here, but I don't buy it. Okay, now what's the format? I've forgotten the whole format. Yeah, okay. So the proposition, right. So it's like proposition. Let's see if I can write today. Proposition. I decided it wouldn't be a terrible idea to improve my handwriting. So I'm going to try and do that. Proposition, then proof. And I guess we have our thing here. And then we have proof, and then I guess we have a full stop for some reason. Then we have something there. And then we have our stuff in here. And we have a then on thus and all that type of stuff. And then we got like a therefore at the end. $30. That's a lot. That's a lot. I'm sorry you got to put up with that, Happy Nora. Okay. Now, I did this one last time. I'm just going to try and go through this again, see if I can remember how to do it. So it's like, if x is an even integer, then x squared is even. Oof. Okay, not could be worse. Now the proof is we start with suppose. We don't actually have to, or do we? The approach with this was something like we put it in some sort of form. I guess we suppose x is even, or an even integer, right? That's probably what it is. Let's try and do it without trying to look back. Suppose x is an even integer. Right, suppose x is an even integer. And then we have that formula. And the formula was something like Yeah, it's something like x equals 2a. Something like that. Was it that simple? Yeah, and then you gotta try and put it like, oh yeah, we gotta have the end thing first. We do it from both ends. Let's just say even int. Save me some time. No, that's terrible. Oof. Come on. E V E N I N T. Right. And then we try and get to like, we try and get to this position. Yeah. So to do that, so we then, we want to get to this. So we take x equals 2a, and then we square it. Which gives us, 4a squared, right? And we're trying to get to, what are we trying to get to? Just keep this loaded in my brain. Terrible x. Oh yeah, we need to change the the symbol we're using. Yeah, and then we do something funny like to be where b is equal to to 2a squared. Is that what we do? Something like that. Yeah, and then we put all that in here, basically. We put all that in here. Imagine I have a selection tool and I drag it over there. And we say so or something. So x squared is even by whatever formula. Something like that. Which is something like, well, I know exactly what it is. It's x. Oof, worst x, yeah. It's hard doing this x. Something like that. So this like perplexed me a little bit when I was thinking about it just in my mind. All of this seems to rely on the idea that if something is shaped the same, like this, I mean, this kind of logic here, right, is that if something could be put into this structure, in fact, let me change my color. If something can be put into this structure, then it's even, provided that it's in the integers. So that's, we already know that, and so by transforming, because we're given this as a truth already, so we don't have to prove this. We kind of have to prove that the situation where this is true, inevitably this is true, or this implies this if this is true. So we take this formula for an even number. We're saying if it can do this, and we've been told it's even, and this is our definition for even, I guess. If it can fit in this structure, and then we can transform this structure into one which looks like also the same version of the structure for x squared, then it's proven. And this also relies on something which I didn't quite get my head around last session, but the operations have to be of a certain kind. Like we're transforming this thing in some way. We're transforming it somehow into something which, you know, we can then put in this form. But we need to only use certain operations, I think, because we need to stay in the world of integers. If at any point we perform an operation that might lead to this not being an integer, then the whole thing doesn't work, I think. So we need to be careful to perform the operations that were mentioned in the chapter: addition, subtraction, and multiplication. That for me is the multiplication symbol. I know it's not the mathematical ones. Let's go with this. Boring X. But we can't use division, right? Or we can't use like division as I understand it, where like 1/2 is equal to like 0.5 or whatever. We can't do that because these things aren't integers, so we're not allowed to do that. Chess Walker, hello, great username. The bird sounds are background noise, mostly to help me concentrate. So if we were to try to transform this into something like, I don't know why we would ever do this in this context, but let's say if we did this, well, I guess there it would be okay. But let's say if we did this, this would no longer be a valid route to proving anything about this, because we don't know it's an integer anymore, right? So I guess, I mean, that's what I'm taking from it so far. If you're looking for the word of God on this, I don't have it, but that's how it seems to me. This kind of operation is like disallowed. We can't root either. We can't raise anything to an unknown power, because that could be negative. or fractional, I guess. I don't know if that makes a difference. I forget what happens with powers. But we can do these. These are allowed. I think. I think that's what I'm taking from this. You've given me a formula there with some symbols I'll need to relook up. Happy Nora. There's that thing. That bar symbol. Yeah. A divides B. A divides B. If 2 divides X, there exists, if and only if, I guess, 2 divides X, there exists an A that is an element of the integers where X equals 2A. Hi, Nemir, how you doing? Yeah. Okay. We're given some operations we can do. Yeah, here it is. This is the fact. If A and B are integers, then so are their sum, product, and difference. Doesn't say anything about division, but it does say that we do get given this, and this keeps us in the world of integers. It's like division with remainder, which is it is a type of division we do in programming, but it's not like, it's not the default, I guess, because it yields 2 values. Yeah, we often end up with like floating point division, which I don't know what we call that in mathematics. So a lot of this rests, so far a lot of this seems to rest on these facts being usable to prove things with. So need to keep that in mind. Not because, I mean, if you don't know that, right, if you're just coming to this totally fresh, you could just forget about all that and probably just say, the exercise won't lead me down a weird path, but it just bugged me a little bit. I'm in the direct proof chapter, which is something 1. Chapter 4. Section 1. Yeah. Now what? Yeah, these divisible or divides. This divides operation is a logical operation, right? It's doesn't give us a value either, so that's worth knowing. So this bar that has occurred in the chat, just going to write it down to get it in my brain. Okay, A bar B A divides B. For division, it's not true for 0. I suppose that's true. Okay, now we're gonna do some more. We're gonna prove some more things. Right. Okay. 2. I can type as well now. Right. And then someplace down here, I suppose, we end up with... Yeah, I like hacked this in today. So it's not very good. It's not very good. All right, so we've got this formula from before, right? So it's like come on, focus. So x equals 2, come on, 2a. It's like +1, I think, this formula. I think, and then we're going to have to transform this into x cubed is equal to 2b. We need to give it a different symbol. 2b +1. Chess Walker asks, have you worked through all the chapters and problems up to this chapter? I have worked through all the chapters. I haven't worked through all the problems. Some of the chapters that seemed a little easier, I did only the odd problems. And some of the chapters had material that was too... Some of the exercises were too hard for me, basically. So I've marked them to go back to. But by and large, I've like worked through the material to the point which, you know, where in theory I know it up to this point. Okay. So if we wanted to transform this, we could do... I don't like that I'm on this color. Let me do that. So we can cube it. Cube it? How far is that again? Cube it. We're going to have 2a +1 cubed. Chesswalker asks, why this book in particular? It was Creative Commons, so available online, and it promised to teach proofs. And I want to know proofs because Knuth uses proofs a lot in the book, and I don't know that much about proofs. Hello, stop using AI. Nice username. Math indeed. You're bad at algebra, me too. I'm bad at a lot of things. But being bad at things for long enough is how you get good at them. I mean, it's also a way you continue to be bad at them, but... Okay, so now I need to do this algebra. Horrendous. Now... Okay. So I guess in theory, you can do this in parts, right? And then you can, you know, we can do it on the... We can have it on the end, etc. So if we do this part, we've got... It's been too long. Okay, we've got the whole thing. We've got to multiply everything together. We've got 4a squared plus 2a plus 2a plus 1. So that's 4a, right? I can move things now too, very slowly. I don't have select, but I can move things. About the worst possible way you could implement that. Okay, and then you got it. You got it. Stop using AI. You got it. And then we're going to do it again. Well, I mean, you may be testing me, stop using AI. It's hard to know in this channel because sometimes people ask questions to point out when I've done something wrong. But I think this is right based on, well, 2a times 2a will be 4a squared. Then we've got 2a times 1 and 2a times 1. So we've got 2a plus 2a, which will be 4a. And then we've got 1 times 1. Yeah. Oh, you're asking about the squared. Yeah, I think that's why. Yeah, we're like, we're two, we're two people stuck in an incredibly dark cave trying to work out what's right. And then we've got all this to do. So this is going to be, okay. So we've got to times everything by 2a. So that's going to be 8a cubed plus 8a squared plus 2a. And then we put everything in again because we got this 1. 4a squared plus 4a plus 1. If you hang around long enough, stop using AI, you'll see at some point somebody will recommend it, like a very elementary book for me to read. I think somebody once said I should read a book on basic algebra or something like that. So you'll be able to take a recommendation. Okay, so we got this. Now, can we just, well, actually, now I think of this, we can simplify this a bit, right? We can get rid of this and turn this into a 6. And then this into a 12. And then get rid of this. And then let's take this plus 1. And I think we can then extract a 2 out of that. So we can then say, and then we've got something of this form, right? But where b is this. I think that works. Okay. For the purpose of not wanting to smash my head against the wall repeatedly, I'm gonna be a little fast and loose with the notation, I think. We found our B. We did. True. Okay. Great. Now, it doesn't move incredibly slowly either. Perfect. Right, so I've done this. Done that. Wait, I need a better color for this. Done that. Done that. Now 3. If a is an odd integer, then this thing is odd. Okay, well, I guess I'm getting the form now. So we basically need to transform this formula somehow, probably. So we could say, we could start off with the formula for an odd number. We can't use that anymore, so let's use b. 2b plus 1. And we need to somehow transform that into this form. Well, we're going to have to square it, right? Or I guess we can probably write down our end form. Our end form is going to look like... How do we do that, actually? We say... No, actually, we're gonna end up with... No. Yeah, actually. A squared plus 3a plus 5 is equal to 2b plus 1. No, let's say 2c plus 1. All right, so we have some options to like rearrange this, I suppose, but we might or might not want to do that. But I guess we'll find out. So, all right. Let's square this, see what we get. Right, and to do this, we get 4b squared plus 4b plus 1 doesn't look great for us. Plus 1 we could divide everything by I guess we need to think about what C is going to be. What would C have to be for these to be equal? C would have to end up being something super weird. I would take a hint, Happy Nora, if you have one. Can you express 3a in terms of b? I guess so. Hello, it just works okay. Again, great username. We're getting some great usernames here. How are you doing? It just works okay. Oh, this seems like a good old number theory problem. I guess maybe it is. Okay, let me take another stare at this. It's the direction I'm missing. I guess. Is it enough to work out? It just works okay as saying, I mean, decompose a squared plus a3 as a plus 3. It's a branch split. Oh, oh goody. We need to handle the cases of A being even and odd. There's something earlier in the book about handling different cases, which I skimmed a little bit. So maybe I need to go back and review that. I think what I'm so I think the algebra part is okay. What I'm not quite getting is what I'm actually directing myself towards. I think that's what I'm missing at the moment. I'm sort of at the point where I'm like, okay, so we could do any number of operations here, but I'm not exactly certain where I'm going. Probably means I should need to review a bit more material. Let's look at something more complex and see if I can. Yeah, I think yeah, let's spend a bit more time. This problem looks kind of similar, right? So let's see what this one is about. Proof. Suppose x is an even integer. Okay, so I need to get rid of all this now. Suppose x is an even integer, then let me actually make some notes on this problem as we go through. Then x equals 2a for some a in the integers by definition of an even integer. So, and then he's doing, what is he doing? So x squared minus 6 plus 5, he's taking this. Yeah, he's taking this and then he's right. He's putting this in. Right. Okay. He's putting this in and he's getting out something. Right, so he's substituting that in, fine. I don't think I did that. And then he's working that out, and he's working that out, and he's working that out. Yeah, and he's pulling out this 2 here. But he's still got a plus 1 on the end. Therefore, we have x squared, equals... Wait, so is he just... he's just disproving something, right? Oh, no, it is. Yeah, okay. Yeah, he's supposed to be showing it's odd. Okay, fine. Okay, great. That surprised me. Fine. Okay. Great. So maybe we can try that approach. Is this a yield to that approach? Yeah, there's like... Yeah, he's substituted everything in there. Maybe let's see where that goes. Hope my computer doesn't melt in the heat. We needed a cooler computer. Okay. Whoa, that again. That old one. Need to disable that. Okay, so, right. So we have a squared plus 3a, and I guess this is what you were saying, Happy Nora, before, but I didn't quite get it. You were kind of pointing me to substituting in. Right, and then we substitute in... Yeah, we substitute in something weird, some other symbol. I guess if we're talking about odd, so it's going to be 2b plus 1. No way. Yeah. No, we can't do that. Yeah, okay. Square that. And then we've got 3 2b plus 1 plus 5. It just works okay. By the way, is this... A pure math homework. A bit confused. Yes, so I'm on a grand project. The grand project is to work through, to some degree, all of the Art of Computer Programming by Donald Knuth. He does a lot of, there's a certain amount of mathematics in his work, a certain amount of proving stuff. And he started to get into that in the book. And I don't know that much about proofs, and I would like to experience the book on some degree, to some degree on the level he wrote it. And so I'm learning about proofs in order to work through that. Why do that? Well, for fun, for the love of it. Yeah. Why not? Indeed. Regrettably, or fortunately, I'm past possibly the point in my life where anyone will set me homework. I have to rely on my own motivation. Yeah, Happy Nora, you would have given the game away, indeed, if you'd said that. Although, to be fair, you might still not have gotten it. Okay, so we're doing that, and then we're trying to make it again look like of the form to something. I don't know if it has to be anything. To something plus 1, I guess. So that we can then say it's odd, I guess. Okay, now let's see if I can do this just based on the pure power of my mind. Okay, I think that's it. Laptop overheating, can't write the number 1, etc. No, it's all going wrong. Okay. And then this one is 6b plus 3 plus 5. Yeah, and then we could extract. No, wait, what have we got? We've got, let's arrange some things. We've got this 1 here. Let's shove that on the end. And then we've got this 10. Need to start writing in proper lines. And we've got 9. Now, if we can extract a 2 from that and a 1, I think we win. Oh, that is unreadable. Oh, I thought you were talking about my handwriting. Probably equally unreadable. It just works okay. Says, I don't know why Twitch has no LaTeX. Now that would be make a Twitch a much more interesting website. What would people do with that, I wonder? Okay, so because it's of this form then, it's odd. That's the way the proof works. So it's like, we found our C, that's true. So it's like, what's the structure of this? It's like, so our proposition is Yeah, okay, it's the whole statement. If a is an odd integer, then a squared plus 3a plus 5 is odd. So that's our proposition. I need to get this in my brain because I will definitely neglect this. We then suppose a is odd. Then what's the next step? We somehow introduce that crazy formula. I'll look that up in a second. Then we do this. And that's this thing here, which I'll call 1. Then we do this. That's not really proof terminology, but it's something like that. I'll look back at the back at what it says in the book. And then we've got change the color. That's annoying. Then we end up with this. And then we've got a squared plus 3a plus 5 is odd by definition of an odd number, which is 2c plus 1. And there's actually this, yeah, we miss a bit. We've got like, we do this and then we say this here. No, wait, it's like, we got this bit on the end where, and we say, where c equals this thing here. Something, that's the, I think that's the structure of it. Oh yeah, QED, yeah, I gotta remember that. We've got to be very careful to have this. You got to have the tombstone. Anyone unfortunate enough to know how much tombstones cost? It's a lot. They're expensive. Ultimate fashion accessory. Tibmis is saying all kinds of mathematics. That's his name here. Yeah, you do need money to die. You need quite a lot of money to die. One of the things that's funny about a tombstone is they this is kind of messed up. This is kind of messed up. They charge you by the letter. Now it kind of makes sense because, you know, if your name is K, the letter K, it's not going to take that long, right, to write. But if your name is Bartholomew, it's going to take them a lot longer. So there's this awful calculus. If somebody passes away, and you're responsible for their gravestone or tombstone or whatever, you start thinking, you're like, I want to put a message. Obviously, you need to have the right message on here, but you don't want it to be, you don't want it to be too long. You don't want it to be too long. You don't want to like. You don't want to say anything unnecessary. You draw portraits on the grave. It's really. What country is that? That's fascinating, Naomi. In your country, you draw portraits on gravestones. That's fast. Maybe that's why they say RIP. Actually, it's a lot easier, a lot quicker to say. Yeah, yeah. And the person whose gravestone I was charged with administering was, and I say this in a very fond way, he was a very cheap person. He spent money when it counted, but he was not one to like spend money on stuff that did not need money spent on it. Like if there was a cheaper way to do something, he would find a way to do it. I just thought like, just initials, forget the name. Just like the final digits of the year. That's it. RIP, initials, final digits of the year. Maybe not even the birth year. I mean, who cares, right? Yeah, but I didn't do that in the end. It's something you want to spend money on, really. Georgia, that is fascinating. Wow. Portraits. That is so interesting. Are they done by like I guess they must be done by like dedicated portraitists. Portrait, there's a word for that, right? Like and they must be based on photographs, I suppose. That's so interesting. Are they like good portraits, or are they like kind of simplified? I guess it probably depends on how well off the person's estate is. But that's so interesting. Yeah, in the UK, again, when you have to start looking for gravestones, you obviously want to look at what other people do. And there's all kinds of articles about like what do you put on a gravestone. Anyway, depending on the gravestone you go to, you get like varying degrees of gaudiness. Like if you go somewhere that's probably quite traditional, it's like, you know, very understated. And then if you go somewhere else, you get like all kinds of like graphics and images and like logos and stuff. It's kind of cool, actually. I mean, yeah. Emma says, depends on what people choose. Some people draw it. Some people engrave photos of the deceased. Oh yeah, because of course you can properly print photographs on stone now. I have no idea how long lasting that stuff is, but yeah. Funny industry, but you know, we need it done, right? Oh, I'm so glad that this performs somewhat acceptably now. Okay, so that was number 3. Now there's so many of these exercises for proving this. That's 28. That's 28. I'm going to be like a world champion prover by the end of this. Terence Tao's going to be calling me up. He's like, hey, there's some stuff that Anthropic's Fable can't do. And the model says we need to call you. The model's been watching your streams. Okay, 4. Suppose x and y are in the integers. If x and y are odd, then xy is odd. Okay, cool. So if we want to do this, well, okay, so what I learned from the last one is there's more than one way to do it. I still don't quite get the goal. Well, I do get the goal. I guess I don't get the moves. I guess that what I'm learning is there's a bunch of different ways that you can get towards that end, which are probably the same way underneath, but you know. Those of you who are watching on YouTube, not right now, I don't stream on YouTube. will have missed the game stream. Been thinking a lot about that. I've already thought through how I'm going to handle the next portion of the game. It's going to be very funny. I'll have to get sick to justify doing it, but all right. So X and Y are both odd. Am I following the World Cup? Only to a very limited degree. I happen to know Scotland won something and lost something. England, I don't know what they're doing, but I don't think they're doing too well or too badly. Otherwise, I probably would have heard of it. I hear that South Korea and Mexico are friends for some reason. I don't quite know why, but an Instagram reel told me that. Did miss that. Did make me laugh actually. World Cup? I thought the world was a sphere. Joke of the Day award. You get the joke of the day flair when I invent it. Why'd you ask, Namer? Are you following the World Cup? Is there something happening right now? Legally, I'm not allowed to watch the World Cup broadcast live, and for the benefit of any TV licensing folks that are, I don't know what that was about, that are watching, I'm not watching the World Cup live, and I'm not watching it recorded live either. So back off. But I have heard, I've seen people in pubs observing the. I wasn't looking at the screen. I didn't see the screen. I didn't absorb any information from the screen. But I will admit, I did see the glow of the screen in the eyes of various sort of, transfixed, as if a sort of Doctor Who villain. Not that I would watch Doctor Who, because I'm also forbidden from watching that. Kind of Doctor Who villain has transfixed them, and they look like. Yeah, they're doing that. I've seen them do that. They seemed very interested. I actually get all kinds of Instagram reels about friendships. Name it. I think the Instagram Reels algorithm is so interesting. It's actually a great algorithm. It's one of my favorite algorithms because it really, like, me and my algorithm have a real thing going on. We really understand each other, and other people's, their algorithms just sucks. But mine has friendships in all the time. Also has a lot of lesbian drama. Has a lot of that. Has a certain amount of those little creatures, hyraxes. You found the sea, Happy Nora. Oh my gosh. Oh yeah, we're transforming it into something. We're transforming it into, yeah, 2C plus 1. Happy Nora's over here doing the stream. Doing the stream for me. You're not doing it. You're doing so good. No, 4AB. Okay, I think that's right. So then it's like, there exists that, you know, such a thing happens. You got really good movie recommendations with Instagram Reels. Ah, that's cool. I don't think I do. Sometimes get birds. A lot of birds show up in my Instagram. I went through a phase of getting really weird AI stuff, like really like freaky AI stuff. But that ended. I don't know if people stopped making it or whether my algorithm, I just became bored of weird AI stuff. But yeah, all kinds of odd stuff. You know that the pink cat, I got a lot of the pink cat for a bit. If you don't know what the pink cat is, and I don't mean the nice Instagram illustrated pink cat, I mean like the horrifying AI CG pink cat. Don't look at it. Includes a lot of baby crying sound effects. If you ever hear the baby crying sound effects on Instagram, you know you're in the bad place in life, in life and on Instagram. Okay, all right. So basically, So the steps here are, yeah. Okay. So we're trying to prove this. The proof is if x and y are odd, then x and y also exist like this by definition of an odd number. Then we can say xy is equal to these two multiplied by each other. Multiply that out, and we put it in this form. And because we've only used the nice correct operations to rearrange this, then we can see these are all integers because we are multiplying integers and adding integers. So we don't need to worry about any non-integers. So as a result, this is going to be an integer, which means we can say that there is a formula. I guess there's an xy on the front of this. We're saying xy is equal to 2c plus 1, where, and we've shown this in this way by saying all this, and the c ends up equal to 2ab plus a plus b. Pink Panther doesn't go on reels. I don't think I've ever seen a single reel of Pink Panther. Pink Cat is far worse than Pink Panther. Stick with Pink Panther. That's my advice. Don't let the pink cat into your algorithm. Don't even search for it. You'll regret it. Trust me. What kind of 5 is that? Freaky 5. Okay, so same deal, but we get to release the y. We get to release the y. Interesting. Another thing that happened recently is I finished watching the latest series and all the prior series of Invincible. I quite enjoyed it. I liked all the knockoff superheroes. Always like them. So we're saying x is 2a plus 1. No, even. We don't know what y is, and we're saying xy is 2a also. Oh, Avanel, you search for the pink cat. I'm sorry. I'm sorry. All of your dreams for a year are now going to be full of that. I shouldn't say that. It's really freaky. No, the pink cat is not real. The pink cat can't hurt you. The pink cat's just AI. Yeah, I miss when the only slop that we had were those YouTube videos we used to pump to children's brains. You know, the ones with the with Spider-Man and that that person from Frozen. What's her name? Elsa? Yeah. Spider-Man and Elsa generated videos. That's golden. That's golden era. That's golden era. Back then when things were simpler. Okay, so oh no. Nima says, watched A Knight of Seven Kingdoms recently. It's really good. Ah, I never heard of that. What genre is that? Is it fantasy or is it something? What is it? I never heard of it. Never heard it in my life. Okay. Hmm. Well, I don't quite know what I'm doing. So we've got that. And is it just as simple as saying this? And then we've got x, y is to be. Wow, this is what is going on with my computer. I don't think it's lag. It's not. I don't think it's. I think it's lag purely in my streaming software. Okay. I think that's that. High fantasy. Spin-off from Game of Thrones. Ah, I never watched Game of Thrones actually. That's something I really haven't seen. Whoa, okay. All right. Right. I think that's it for 5. Can anyone confirm? Anyone want to check my homework for me? Is my logic in 5 correct? I guess if I try and think it through as a proof, let me try and verify it for myself rather than asking the people to do my job. Suppose that x and y are numbers in the integers, are integers. If x is even, which means there's an integer that we can times by 2 and get x, then xy is even, which means the same thing, but probably with a different integer. Probably not certainly. Now we've managed to show that xy is also equal to that integer a times 2 times y, which makes sense. And then if we take that ay off, we can assign that to b, and we've got something of the formula xy is 2b, where b is that ay, which is essentially saying that if we want to show that xy is an integer, no, if we want to show that xy is a even integer, then we can say there's an integer b, which if you multiply by 2 will give us that number, xy, and we can construct b by taking the integer y, which could be even or odd, and multiplying it by this a. No, I've lost it. Really thought I was going something with that. Really thought I might be going somewhere with that. Happy Nora confirms it's correct. Thank you, Happy Nora. I appreciate it. Okay, let's take that as it is for now. We've got a divide C1. Let's see what's up with that one. So we've got A, B, and C in the integers. If A divides B and B divides C, then A divides B plus C. Quite a lot more structure in that. We've got an if, we've got an and then we got a then. Now let me look up this more. There's we get something about this in this chapter. I did think it was late. Yeah, okay. Suppose that A and B are integers. We said that A divides B, written A divides B if B equals AC. Okay, for some C in the integers. Okay, so this is our sort of bit. This is our thing. No, that's not right. A divides B if... Come on. Right. Okay, so we got that. So given it's an if then, we need to care about the situation in which... Yeah, we only care about the situation... We want to show that when these two things are true, this is also true. And I just need to surround this in some sort of field of surroundingness to indicate that it's not part of anything else. It's not part of the A's and B's in my question. Whoa, okay. That'll have to do. I'm sorry. Okay. So we're supposing that A divides B, and now and is that right? And A divides C. Yeah, 2 divides x. Yeah, I think you mentioned that earlier, Happy Nora, yeah. Yeah, so we're supposing those. Which means if those are true, then there is a... Let's go with a... Yeah, I mean, there is a B. Can't use C here, so we'll use D. And there's also a C. We've got an A and another thing. Yeah, and then we want to show that also we want to show this, and this I guess this if is a kind of if and only if type thing. No. Yeah. Something like that. Which means that we're looking for a B plus C equals a, and then I guess an F. Yeah, we'll find our F. Okay. These things don't look so complicated, so I guess we could just add them together. Bad habit of mine is gripping any writing movement as tightly as I can. Very annoying. Okay, relax. Okay. B plus C is going to be AD plus AE. And then I guess we can then say we can extract the A, which someone got, Namer got in like 2 nanoseconds earlier, I think. And so, yeah, and so we've then got this. Yeah. Okay, cool. Right. And that's that. Thank you, Happy Nora. Thank you for the good job. Wow, we're proving so many facts today. I didn't even pay attention to any of these facts, but I guess they are real facts because we're proving them right now. So they have to be true because they've been proven on stream. Okay. Okay, it's It's lagging. 7. Same deal. What's that formula again? B equals AC. So it kind of ends up being B squared equals, I'm going to make a mistake if I'm not careful. Something like that. That's kind of where we're going to. And then we've also got the same thing on the other side. We've got the original form, which is B equals AC, but it's going to be D because I've done everything in the wrong order. Bad. Okay, this is complicated enough that I'm definitely being too sloppy. Right, so where am I typing? Whoa. So yeah. A divides B implies, I guess this symbol is valid here. Implies B equals AC. And we're going for something like no, other way around. Okay, now we got to somehow transform this. We can't obviously like just send it somewhere else, so we could substitute in this. We could say A C A C, which will be A squared C squared equals A squared D. I have to define C. Guess I have to define this too. Come on. Oof, so laggy. Okay. That's not going to help. That's not going to help us at all because we've got no B left. So we can't take that anywhere. What was I doing in the last one that made this easier? I guess it's the squaring. I guess I could square... Well, no reason not to square any of this, actually. Why didn't I do this in the first place? Nope. Yeah, and then, yeah. So then we've got this, but where D is equal to C squared, I guess. I think that's right. Okay, well, we'll get an answer eventually. Let's say it is. Thank you, Nimir. Right, let me get 8 done. And then I'm going to go and I'm going to reward myself with a beverage. Okay, suppose A is an integer. If 5A divides 2A, then 5A divides A. Okay. Maybe there's a way of putting this in notation. So A is an integer. If 5A divides 2A. Is that the right symbol? I think so. Then 5 divides A. Now, I guess the proof part of this, you know, I need to do a video, episode of the stream, I think. See some other people doing this would be interesting. Okay, so if 5A divides 2A, then B, which is the second one, 2A equals 5A multiplied by some C. We can also say the same thing about this other side of it. Ah, yes, Sapinor, you're right. Now what was I doing? 2a equals 5c. And also, we're hoping to end up with wow, that was a lag. Okay, need to improve the performance of this whiteboard system. Also, A equals 5C, 5D. So my impulse is to do this. Yeah. I don't think that's allowed though. Also, I don't even know if it helps actually. Yeah, I guess we could have, I mean, technically we could have this. And then we could say D is equal to C over 2. But I don't know if that's allowed. Yeah, I have to show that C over 2 is in the integers. Which I don't know if I can do or indeed should do. And there's no indication that it is, right? Is there any indication? Is there anything about 5 dividing 2a? I don't think so. Then it says 5 is odd, so C has to be even. Because 2a is even. Well, 2a is definitely even. If 5 divides an even number, what can 5 divide? 5 can divide 0. It can't divide 1, obviously. It can't divide 2 or 3 or 4. It could divide 5, right? Can 5 divide 5? What does this operation do again? What does this mean? What does any of this mean? Suppose a and b are integers. We say that a divides b, written a divides b, if b equals ac for some c in the integer. Right, okay. So 5 does divide 5, right? If this is true, there should be a... Ugh. Oh my gosh. Wow, okay. What a mess. Five C, where C is in the integers. And indeed, in this case, it would be 1. Being in the integers is not being even, so that's fine. For some reason, I thought being in the integers was evenness, which is not. I don't know why I thought that. Okay. Right, okay. So the reason you say, name it, that because 5 is odd, then C has to be in the integers is because if this was... Oh my gosh, what have I done to my system today? If it was like 6 divides something, then it could be... something else. Oh my gosh. Just dead. Just dead. Okay. 1 second. Now I've got algebra on my face. Wow, now this is messed up. All right. We're saying here that if 20, this would be... Right, so we are showing that it's... No, I'm not following. Oof, getting frustrated. Oh, it's been a while. Been a while since I've gotten properly frustrated. Must be doing the right learning. Okay. I won't inflict my frustration on anyone else. Let me just stare at this for a moment. Okay, so the indications studies suggest we're going along the right line here, but we have to show that, I guess, there is the C is even. If we can show that C is even, then we will then have proven that C over 2 is in the integers, which means D is in the integers, which is important for us to be able to do something else, which I missed somewhere over here. Oof, come on, come on. Come on, computer. Diabolical. What did I do to this device today? Anyway. Oh wow, it's like massively eating CPU. Okay, wild. I really did damage it. Okay, fine. Okay, all right. I got to sort that out. Wow, it's dead. It's ended. Okay, so basically, yeah, just staring at this now. We want to show this. We now want to show, so that we can show that D is in the integers. D is something, which I forget what I was supposed to be doing with D. Oh yeah, I made up D. Yeah, okay. Yeah, I made up D because then if I can have A equals 5D, then I've got my second part. I've got my right-hand part of the thing. I've got A equals 5D, right? So D equals C over 2. But there's an additional constraint on D, which is that D has to be in the integers for all of this to work. So to show that, we need to show that C is even. We know that C is in the integers. We need to know that C is even, which means there may be some funny thing which you can get the intuition of it of, but I know how to show things are even, so I can probably do that. The way I do that will be to get my something equals 2a formula out. Maybe combine it with the other thing, the first thing. Yeah, and then if I can do that, I'll have something. Okay. Now this is really imploded now. Okay, wow, that's really gone. Okay. Are we back? Right. Okay. Nice. So once we've got this, we've also got, yeah. So if this is true, we also want to say that C is equal to sum 2E something like that. And what have we got to show that with? We've got this. So let's see where we get with that. I mean, that's definitely not anything. Yep, don't think that gets us anywhere. So what about what we know about this other thing then? So we know 5 divides 2a, which means we know can we delete these again? Yeah, okay, we can delete that. Great. All right. Okay. Let's look back. Let's see if we get anything else in here, maybe. There are a bunch of proofs with this. Operation here. We've looked at the evens and odds. No, okay. Short break. Short break. I'll be back shortly. I'm going to go get myself a can of drink. And then I'm going to come and stare at this again for longer. See you in approximately 2 minutes. I have returned. Wow. Very frustrating. Getting very frustrated. But I've cooled off. I've got myself a dash water. If Dash Water would like to sponsor the stream, please send me 1 crate of Dash Water. I'm rewarding myself for my effort. I was thinking this week, I had a kind of a frustrating week, and I was thinking partway through it, I was reminding myself that so all kinds of frustrating things happened this week. I was reminding myself professionally. I was reminding myself that effort, that things are just difficult all the time, including positioning the fan properly so it doesn't breathe into the microphone. Okay, let me not talk for a second. I think that's all right. Okay, good. Yeah, things are just difficult. And I have to remind myself, because I just think things should be easy all the time. And I get very frustrated when they're not easy. And it makes me feel bad. Because things should be, you know, if you assume things are easy and you find them hard, it means you're not very good, right? But things are just hard. Learning new stuff is hard. Trying to get things done at work is hard. Trying to make anything good is hard. Trying to read books is hard. Above a certain level. Trying to do stuff that's unfamiliar is hard. Trying to exist in the heat is hard. All that stuff is hard. So it's hard because it's hard. So if you're finding it hard, Kay, then that's just because it's hard. And it'll get easier. And then you'll find something else hard to do. Because it's boring to do easy things a lot only. I feel like I'm leaving a recording for posterity. It's not that bad, don't worry. I'm just talking myself around. Just talking myself around to doing some simple undergraduate level mathematics that's also hard. Okay. All right. Another attempt. Another run at it. I'm looking at chat again, but I'm not thinking about anything mathematical. Keynes has fallen for my trap again of tricking people into thinking that I have bang commands, but I don't. This book is The Book of Proof by Richard Hammock. Okay. Now, where were we? Number 8. Nice and slow. Suppose A is an integer. If 5 divides 2A, then 5 divides A. Just to get myself vaguely into the space of thinking about this problem. What does 5 divide? 5 divides 5. It also divides 10. It also divides 15, 20, 25, etc. And the point of this divides thing is that there exists some... You know what? I need to turn my birds up. There exists some number that we can multiply by 5 and get this side. So another way of putting that is we can get B by multiplying A by some number C, some integer C. Imagine that's a Z, overstruck Z. So that's what that is. Now, given that, it's not really surprising that this would be true, because if 5 divides... suppose A is an integer, so we're supposing A is an integer. If 5 divides 2A, for which this would be a 2A, this couldn't be a 2A, because then A wouldn't be an integer, because it would have to be multiplied by 2 to get 5. So that's... Oh, okay, that's not what I wanted. So it's this one, or this one, in which case A would be would be 5 in this case, or A would be 10 in this case. Or if we went even further, you know, we'd end up with A is, I guess, 15 here. No, 15? Yeah, 15. So it's not very surprising. It seems like kind of true by intuition. We just need to prove it. Okay, my intuition is giving me some sort of alarm or something. Okay. If 5 divides 2A, and really 5 can only, if we're looking at the things where A is an integer and 2A 5 divides, then we've really got 0, 10, 20, 30, 40, etc. And if that's 2A, then A is going to be 5, 10, 15, 20, and 0. And so 5 is also going to divide all of those as well. So that kind of makes sense. Now let's think about it in terms of the way we prove it. Let's try coming up with some sort of objective. We want to end up with something. Okay, let's try this. Let's say this is objective 1. We want to try and get so given we've got 5 divides A, we're going to end up with A equals wow, these symbols are not very convenient, are they? A, which is actually B. So this is in the situation where we've got A divides B. We've got the right hand side of this, we've got A equals 5, and then some kind of other symbol, some kind of other number, which we're going to call X, just so it doesn't overlap with anything. We've got A equals 5x. If we can put something in the form A equals 5x and get it from 5 divides 2A, and I guess we got to say, we got to remember this. Remember X is going to be an element of the integers. Remember to do that too. All right, so that's our kind of goal. How do we get there? Well, let's look at 5 2a. 5 divides 2a. If this is true, then we're going to have also another expression being true, which is 2a is where we get to before. 2a equals 5y. But this y will be different. And then we're going to have a equals 5y over 2 or 5 over y, 5 multiplied by y over 2. So we could then say that this would be true where x equals y over 2, but we still have this issue we came up against before, which is that we need to show that y over 2 is in the integers and not, say, 2.5 or some 0.5 or something like that. So we've got this other problem. To solve this, well, when is y over 2 in the integers? Y over 2 is in the integers when, or I guess it's something, might be a double, and it might be a double one. Need to remember what that means actually. If and only if there exists some other number, let's call it z. Let's not call it z, let's call it q, where q's in the integers, I guess. Basically, y's got to be a multiple of 2. That's another way of looking at it. We got to say, I don't know if this is going anywhere, but we got to say that 2 divides y, right? That's kind of an interesting way of putting it. I wonder if that goes anywhere. I guess we've got a number of roots which we can use to prove that y is even. Two divides y if there's a y. Well, same thing, I guess. It's kind of interesting. Well, I guess it makes sense that it's the same thing. Still, doesn't tell us much. Now, we have to somehow work out that this is true. I guess we've got to get it out of this because this is what we've been given. This is what Naomi was saying earlier. But it wasn't quite clicking with me. Okay, so if 5 divides 2a, if 5 divides 2a, we've got 2a equals 5y. Both of those are going to be integers. There's something. I mean, you can sort of see it, right? It's like obvious that this is going to be even. But I'm not really sure how we prove it beyond just being like, yeah, well, I mean, it's obvious. I guess this might be useful. Maybe we did we did sort of prove something maybe related. Maybe we're supposed to use an earlier result. Probably not, but if x is even, then xy is even. You need to remember we haven't proven any of this. Come on. We haven't proven any of this. Is it just a property of even numbers that is really so basic and I'm just not applying it? Probably. something we know about even numbers. So we know 2a is always going to be an even number because it's got a 2 in it and it's an integer. We know that. Now, if we take a 5 and we multiply it by... If we multiply it by a 0, we get an even number. If we multiply it by 1, we get an odd number. If we multiply it by 2... we can definitely get odd numbers out of that. So maybe it's something specific about this 5. So with this, we're saying there exists some number that we can multiply by 5 to get 2a. That number y, what is that number actually going to be? That number is actually going to be... I guess it's going to be 0 to... We can see it's going to be those because those are the multiples of... Like if we know it's going to... If we know if the things that... We know what this sequence is going to be, this 2a sequence, because we know that 2a is going to be even because it's 2a. We know that it's got to be divisible by 5. It's got to, or 5's got to divide it. So we know that it's going to be 0 to get 0, 2 to get 10, 4 to get 20, 6 to get 30. So we know y is going to be even. I think that's the best I can prove it right now. So we know it's going to be even because we can sort of see it. But I will be interested to see what his solution is. Oh, we don't get a solution. That's a shame. Because it's an even number problem. That will probably have to do for now. So interesting, I get blocked on that. You can sort of see it. But I'm getting nothing on how we prove it. Other than maybe there's some property of divides that proves this is the case. Like maybe we're saying something like if this is odd, then we get some behavior out of it. Yeah, I think that's the best I'm going to come up with. Okay, looking at chat again. Happy Nora says, I cheated and looked at the solutions. The author basically does the same thing Namer did. He argues that y must be even because otherwise 5y would be odd. Yeah. Okay. Let's take a look at 9. And I'm actually going to look at the answers up to not including 9 because I want to clear my board because it's lagging a bit. And I don't want to work on the performance side of this now. So let me just do that. Number 4, chapter 4, chapter 4, chapter 4. Chapter 6, chapter 4. Okay. Now, how many notes did I actually even keep? Okay, we got one. Whoa. What am I even doing? Okay. Right. So there was some wildness. Oh no, this was some other problem. This was 3, I think, actually. Yeah, I think I deleted the earlier ones. Okay, so 3. Yeah, no, I did. Okay, 3. Yeah, he kind of ended up going in that route, so nothing extra to learn there. Now looking at 4, we don't get. 5, we've got... Yeah, suppose... Yeah, x is even. Then x equals 2a. xy ends up being... Yep, 2ay. Therefore, xy equals 2b, where b is the integer ay. So xy is even. So we can actually use, I mean, I don't think this is relevant in this case, but we can use other operations. We just have to have this ending formula be obviously an integer. Okay. Nope, that's not what I wanted to do. Wrong window. Wait, where am I now? Oh my gosh. Five, 4. Okay. 7. Suppose A divides B. By definition of divisibility, this means B equals AC for some integer C. Squaring both sides of this equation produces B squared equals A squared by C squared. Then B squared equals A squared multiplied by d, where d is c squared, which is in the integers. And we know that it's in the integers because we know that c is an integer, and so c squared will be an integer. By definition of divisibility, this means a squared divides b squared, okay? And then I'm not looking at 9. Oh, okay. Well, that was actually kind of useful. Helps me get the structure a little bit better. All right. Thank you, by the way, everyone. I appreciate you all. Right. 9. Okay, 9. Suppose a is an integer. If a divides 4... Sorry, if 7 divides 4a, then 7 divides a. Okay, so we're supposing that... We suppose that... 7 divides 4a, and we need to prove that if 7 divides 4a, then 7 divides a. So we can we're kind of, I think my intuition is gradually building here. It's the link that we're proving. That's why we're doing all this algebra stuff, because we want to like show that if this is true, then this must be true also. If it's false, we don't care. We just need to show that if this is true, therefore the equation 4a equals 7c. If this is true, then this must be true. So if we can rearrange this, we can rearrange this into something that looks like this, then we win. Of course, where this is in the integers, and this actually needs to be different, now I think of it, because the numbers might not be the same. And apparently that he uses the same kind of line as the last question in this, in the solution. So we get to find out what happens. Okay. Or another way of putting this, I guess, is we need to work out what D is by using this, I guess. So, you know, we can do the same thing as last time. We can do this. Hello, Incline Ball. How are you doing? So we can do this and then say that D is equal to C over 4. And also we need to show that C over 4 is equal to something even, by which it's, you know, definition of an even number, something like this. Slowly melting, oh no. 28 degrees in a Klein bottle. It's not safe. In your office, doesn't that mean you can just leave? You can like burn down the place and leave or something? Not that I would recommend such a thing. True, actually, Namer, it doesn't have to be true, does it? Well, nothing has to be true, but in particular, this thing even has to be true even less. But we need to say, yeah, we need to say that C is divisible by 4. So we need to say that we need to say this is true. Otherwise, C won't be in the integers, right? And then we're screwed. Yeah. Yeah, C over 4 must be in the integers. That's true. Yeah. Hello, Atom Fighter 10101. Wow, everyone's joining again. And a Klein bottle says, partially because of my computers and partly because of the sun coming through the window right now. Unfortunately, I get little relief from opening the windows, but I get a lot of noise from the road nearby. Ugh. Yeah, the birds are going wild, Atom Fighter. This is actually pretty similar to the birds I get in my real life. Are they too loud? Should I turn them down? You can request me to turn them down if they're too loud. I got a comment on... I got a YouTube comment after the last VOD upload, and it said, I think there's a bird's nest near your microphone. I took that as a compliment, but I don't know if it was. Oh, cool. There's kites flying around nearby. Oh, that's cool. Oh, yeah. Of course, Atom Fighter, you're right. Yeah, the raining. Am I allowed to do proof by contradiction? I guess I don't. Well, I'm not allowed because I don't know how to do it. But I guess I'm gonna hand wave this one and try and work out. So we're showing that we know C has to 4 has to divide C or something. That's we believe this to be the case. This must happen. And now if we were to go and try to work this out by just looking at the numbers, then what divides 7? Or what does 7 divide? 7 divides 0, 7, 14, 28, 30, 35, 35, 35, 35, 35. Is this even right? None of this is right. None of this is right at all. Chat, how could you let me do such a thing? Don't any of you know your times tables? 40, 42, 42, 42. Oh, what a missed opportunity. 49, 56. Yeah, anyway. 21. 21. Okay, so, and then Yeah. So, yeah. So we're looking for something that is in this sequence, but which is also fours of an integer, which is going to probably be these ones, I should think. Yeah. What's this chapter about? Inner Climb Bottle asked. This chapter is called Direct Proof. Now, I only know two types of proof, and this is one of them, and the other one I don't understand. So so far, this is this is proof. Direct proof. I don't know what's direct about it other than seems kind of direct to me, I guess. I think it's for proving if-then statements, if-then propositions, I think. That's what this proof is about. But there's a bit of a funny part where also there's 0. Oh, yeah, true. And this one. There's a bit of a funny part which I'm struggling to prove to my own satisfaction, which is we need to be able to prove the divisibility of... We need to prove that certain numbers are in the integers, which, but even though there's a division involved, which means I need to be able to prove that something is divisible by some number, and I'm losing it a little bit on... You missed the recent joiners. You missed a really horrendous, approximately half an hour, where Naomi was trying to be very wonderful and helpful, and I was like, I not as a result of Naomi's help, but I was getting frustrated at the problem, and I lost my cool slightly, which to me, I probably it doesn't look crazy. I didn't like rage or anything. I'm not doing rage content or anything, but I did have to take I did have to get a cool drink. I had to give myself a pep talk. Millerin, hello. Coming from the game stream to the stream of the games. So the policy with help and advice, the policy is you can give it. There's no don't need to worry about spoilers or anything like that. People, I think, generally like to not like give away the answers too much, but if it's let's say the answers are rarely sufficient. Well, the point of this is for me to try to learn, and the answers are rarely sufficient for me to learn anything. So if you do give away the answers, it might help me get the understanding, or it might not. Basically, don't worry about it. You can say whatever you like. It doesn't necessarily mean that I will be able to absorb what you're saying. I think one of the things that happens frequently is people who do know the topic jump to something which they can sort of see as obvious, but which I don't really understand or don't know, and then I don't do it because I don't understand it. But you're welcome to try. Pie in the Sky has a wild opinion, apparently. Pie in the Sky says, I have a strong opinion about logic as a whole. The thing is essentially pointless as practiced because the question of the semantics of the underlying language is avoided by all possible means. Exciting stuff. Somebody's bringing the philosophy to the math fight today. Anton Fighter says, well, just list out what we know. We know that it's in the integers. We can narrow it down since it's the only integers that allow 7 to go into it. Yeah. Miller, and you've just done exactly what I was saying. If we're doing number 9, try doing the contrapositive and consider the fact that 7 and 4 are co-prime. I really do love contributions like that, but please accept with my love the knowledge that I don't understand what you're talking about, but I do know now that there are 2 more words I need to know. But it won't help me solve this problem immediately anyway. 7 and 4 are co-prime means, I guess, there's something about them, which means there's no common divisor, maybe? They don't divide by the same number or something. Means that the greatest common divisor of A and B are 1. Yeah. Okay. So go ahead. What follows? By the way, just for everyone's benefit, with question 9, I've solved it to the degree I think that I can solve it, and then I'm going to look at the solution, because I think there's a step in the solution which I would like to understand, at least his intended solution. So if 7 is not, this is from Milloran again, if 7 is not a divisor of A, then 7 cannot be a divisor of 4A, since 7 and 4 are co-prime. All kinds of new stuff, all kinds of new wild stuff here. We could do this too. Okay, let's see what Richard says. I'm open for hearing Richard's perspective on this. Richard, why are you doing this? Why are you doing this to us, Richard? Okay, here's Richard's take. All right, now this is going to be instructive because I don't know what he's talking about here, and I need to know. Atom Fighter 10101 says, I don't know why I keep saying the number. Okay, wait, I forgot something that might help. Okay, you start right, you assume the 7 divides 4A is true. Next, you're supposed to replace the definitions. In this case, is the X divides Y. Okay, I'm gonna read the answer. I'm gonna read the answer for this one. And I'm gonna try and understand it. Okay. I need to get my fringe cut. Richard's doing it. Richard. Richard, please. Okay, suppose A is an integer. If 7 divides 4A, then 7 divides A. Now he's going to prove this to us. Proof. Suppose 7 divides 4A. I got that. By definition of divisibility, this means 4A. So I got that. All right, let me see if I got any part of this. Yeah. So this I got. This I got. For some integer C, I got that too. Nemi's been nagging me to keep this in rightly. Since 4A equals 2... Whoa. I didn't extract the 2? He's extracting the 2, everyone? Everyone, he's extracting the 2. What is he doing? Just back to the drawing board. He's extracting the 2, everyone. Why didn't I do that? Why didn't I think of that? Okay, he's extracting the 2. Right. He extracts the 2. So we get... Well, okay, he's saying 4a is equal to 2a. Great. It follows that 4a is even. Okay, 4a is even. I'm following. And since 4a is equal to 7c, 7c is even. Oh. Okay. Okay, so since 4a is equal to 7c, and 4a is even, because we know this is even. Is there some symbol for even numbers? Probably. So we know that this is even too. We know that this is even too. You know, speaking of philosophy of mathematics, I don't, but people in the chat love to. I was reading recently that there was something about continuously differentiable. Everyone believed for some time that all differentiable functions were differentiable at all points or something, and then somebody came up with this wild counter example, and it upset everyone, and everyone got really mad. Anyway, just reminded me. Okay, so we know 7c is even. Okay, where is this going, Richard? But then c can't be odd. What? Then c can't be odd, because that would make 7c odd, because 7 times an odd number... There's some rule there, right? My facility with even and odd numbers is clearly not good. An odd number times an odd number is an odd number always. Correct, right? So we've got, let's say 7 times 3 is odd, 7 times 5 is odd. Okay, fine. Fine, that's a fact that I need to remember. Odd times odd, somebody said that earlier. Odd times odd is odd. Odd times even, even. Even times even, even. Okay, so even's like, I could prove odd times odd equals odd if I wanted to. I could do that. I could do that. Let's just trust Richard on this. I'm sure he would prove it, but he has not the space to do so. Okay, so C can't be odd, thus C is even. So C equals 2D for some integer D. Okay, so he's bringing that in. Right. So we're saying that he's relying on this. He's saying 7C is even. Therefore, because odd, because of this thing, odd times odd is odd. Because of this fact, then C must be even. Because if it was odd, then 7C would be odd and not even. And we know that it's even, so C must be even. Otherwise nothing makes sense. Okay. Okay, back to it. Right. C is even, so then, given C is even, C equals 2D, where D is in the integers again. Obviously, this is not real notation. I'm a computer, I'm not even a computer scientist, but I'm a computer person. I don't, notation, you know. Okay. Right, okay. Carry on, Richard. Now go back to the equation 4a equals 7c and plug in c equals 2d. We get 4a equals 14d. Okay, great. Okay, great, Richard. Good. This is very funny. it's like a these proofs, like, they read a little bit like, obviously they're not built like this, but they read like somebody down the pub telling you a story, and you're like, where are you going with this? Like, how'd you come? Is there some point to what you're telling me? Okay, so so you're saying 4a, you know, by substitution, we take this thing, 4a is therefore equal to 7 by 2d, which is 14d. Okay. Dividing both sides by 2 gives 2a equals 7d. Now, since 2a equals 7d, it follows that 7d is even. Okay, all right. So we're saying that's even. And thus d cannot be odd. That follows 7d's. 7d's even. And thus d cannot be odd. So it must be even also. Then d's even. So so d so d is 2e. He keeps doing it. D is 2e for some integer e. All right. Plugging d equals 2e back into 2a equals 7d. He's sort of chaining this whole even odd tactic. Really, he's taking this really far. Right, so he's now saying 2a equals 7d, which we had before, from here. If you plug in d equals 2e, we've got 2... We've got, well, okay, we got 2a equals 14e. Dividing both sides by 2 produces a equals 7e. He's not going to do it again, is he? No, he's not. Okay. Finally, the equation a equals 7e means that by definition of divisibility, 7 divides a because of this. And this symbol is obviously wrong now because he's used all the letters on his crazy even odd trick. But yeah, it's of this form. Let's change this actually. Let's get rid of this. We don't need this actually. There you go. It's that simple. Atom Fighter says we're gonna have to write Richard in our own words and use that template to solve other problems. Hi Hofstadter, how you doing? Wow, okay. Well, this was interesting. He just he didn't hand wave around anything. He didn't look at any numbers. He just kept applying far beyond what I would have done the kind of even and odd rules. Plus I wasn't so confident with them. Basically his tools were he was doing a lot of even and odd stuff. He was saying we know this is even, so we can create this formula. We can plug it back in. We know this is odd and even. We know the rules of even and odd really well. And so we're gonna say this is odd, so we have this form. This is even, we have this formula. This is even, we have this formula. And then he keeps going, because I guess the route he's going. Maybe if we were to try to forward logic this, we might be able to say, okay, so we've got 4a here, and there, since we've got this, we might be able to take out, since we've got 4a equals 7c, and we want to get to a equals 7 something, we need to get rid of this 4. This 4 is the issue. One way we can get rid of 4 is by dividing by 2 twice. So if we can show that this is all even, then like a bunch of different times, then we're going to be able to get rid of the 4, have something of the form a equals 7 something, and then c is going to be something. I don't know how you extend this to question 8, honestly, but I'll take another look at question 8, because this is, maybe there'll be something we can do with it. Or will I? Do I care enough about question 8? I'll take another look at it anyway. Offsetter says, doing good. Finishing the tic-tac-toe game I began working on today with my son, written in C99 to ensure neckbeard is growing steadily. Ah, good. That sounds like a really wonderful day. How's your son getting on? Yeah, I assume this is a child son, not like, I mean, could be also cool if your son is like 40 years old, but that is cool. How's your son getting on with programming, I guess? Assuming it's programming. Offsetter says he's 8 and he's picking up things really fast. I'm still driving, but he's mapping out the logic. That's great. That's really cool. 8 years in C programming. Yeah. Yeah, that's cool. That's really nice. Yeah, when I was 8, I could only program in Visual Basic, Visual Basic for applications, so nowhere near as good. Okay, well that was really interesting. Thank you, Richard, for your thank you, Richard, for everything. I forgive you for all of those horrible aphorism-based set questions in the early chapters. Those were really bad, though. Those are really awful. those really sucked. But this one's good, Richard. You can trust some of the people some of the time, but you can trust Richard. All right, what was that? Yeah, so 8. Suppose that a is an integer. If 5 divides 2a, then 5 divides a. So let me just see where this goes. If I can make a better... I can't even draw an 8 now. That's how off my brain is. It's like a $sign. Okay, all right. Okay, folks, I'm calling it on the discussion of whether logic has any basis in reality. So, pie in the sky, please drop it, and everyone else, please drop it as well. All right. Eight. Let's go. So we've got 5. 5 divides 2a. And that would indicate that we've got 2a equals 5c, where some c is... Spicy pasta was a bad choice for dinner. I had spicy pasta for dinner yesterday, but it was extremely mild spice. Does anyone know a gentleman called Lloyd Grossman? Hello, Hex 1 Ef or Hex Leaf. I kind of like Hex Leaf. How do you pronounce it? Hex Leaf. How you doing? Yeah, the chili pasta is great. Lloyd Grossman. You know who else I like? You pronounce it Leaf. Wonderful. Cute name. Lloyd Grossman. I used to be into the herby one, but the spicy one is that's been my go-to for about 10 years now. But then I also like the little guy. Let me try to draw him. Wait, I'll load him up. I'll see if you can. I'm going to try to draw him, and I want see if you can see if you can. Wow, I just messed everything up. Okay, I'm going to try to draw a guy, and I want you to guess the brand. In a climb bot, yeah, they do a site. So don't worry though, the offers are always on cycle. You got to tune in. You got to tune into where the offers are coming from, but they do come back. I know. Okay, so this is the guy. Can you guess who he is? Through my terrible drawing. He really doesn't have any shoulders. No, but no guesses? No guesses? Wow, okay, that was not right. No guesses from anyone on the guy? I think it's pretty obvious at this point. He's got no hands yet, but let's see. You're about to test me to see if I'm an AI. Am I an AI? Captain Crunch? No. No, it's not Captain Crunch. Ridiculous. Home Pride! In a climb bottle, you got it. It's the Home Pride guy. He's wearing like a bowler hat or something. Home Pride guy. Anyway, they do a great creamy tomato and herb pasta bake. Great thing about that pasta bake is you get your dish, you put the pasta, dry pasta, uncooked in, you put the sauce in the dish, you fill the jar with water, you put the water in, then you put it in the oven and you stir and do, put on cheese halfway through. Takes like 40 to 50 minutes. And then the pasta bake's done perfectly. You don't have to pre-cook the pasta. You don't have to cook any pasta aside from yeah, the hands are a bit too human, I think. He serves in the military? No, he would never do that unless there was conscription, in which case he probably would. I don't think he'd get away being a conscientious objector. Yeah, Home Pride guy does a whole lot of stuff. He mostly does other sorts of baking, but they're in pasta bake. They don't do other pasta sauces apart from the baking kind, I think. Anyway, great pasta bake. Would recommend. Don't have to cook the pasta separately. If you like, I basically live off of depression meals, and this is like a classic depression meal. I'm not depressed, but I do love a good depression meal. Neighbor says, no way a non-UK person getting that. What do you mean? What do you mean? I think it's pretty recognizable. He's a global icon, right? He's a global icon. They're saying the World Cup is happening. Is the World Cup happening right now? Does anyone know? Spain versus Saudi Arabia. No spoilers, but I think the winner may be obvious by this point. It's looking pretty convincing. Okay, yeah, well, that's Home Pride Man. Anyway, back. What was I doing? I'm going to leave him on there. Okay, now where was I? Right. 2A equals 5C. So we've got this 2 here. And this is odd. It's kind of cool. So, okay. So if this is odd, we know this is even. We know this is even. So we know 5C is even. And we know 5 is odd. Because it's 5. And therefore we know C is even. So C is then let's say 2D. What are we trying to be proven again? What are we trying to be proving? What am I talking about? 5, oh yeah, 5. We're trying to prove 5 divides A. And therefore A equals 5x, where x is in the integers. I'm getting a little, just marginally more facility with the notation, I think. Okay, so 5 equals 2D. So we can then say 2A is equal to 10D, which means A equals, oh my god. Sorry, I try not to blaspheme that much, but that's crazy. It works. Richard, you've taught me something. Uh-huh. Uh-huh. Right. Wow. Okay. Now I want to add on to this, like where X is D, but I don't know if I don't know if I haven't I don't know if this actually means anything at all. But that is kind of cool. That is cool. Okay, inner client bot says note on style would put the X in integers in brackets rather than superscript. That will get confusing quickly. True. Okay, noted. Thank you. I think it's I kept forgetting it, so I just chunked it on there. But it'll be yeah. I should be more precise about the notation. That's the thing about notation is I do see pedagogically why they're so, I imagine, down on it at undergraduate level, because it is true. If your notation is messy, everything just becomes harder. It's weird that it's like if the notation is messy, your thinking ends up kind of messy. It's sort of funny that way. Yeah, a bit different to how we were doing. Yeah, a bit different to how we were doing it. True. Kind of cool. Kind of cool mechanism. I'm going to immortalize this on Mr. Homepride's head. In a Climbot says, don't be afraid to use more words. People learning maths learn symbols for things, then they're convinced they have to use those everywhere. In reality, it's almost always better to use some plain words. Yeah, I'm avoiding using words just because I have to type them or write them. But it will be better to use more words, especially with proving things. I think you're right. I need to be better at that. Hexleaf says, I applied for a CS program in my 30s and I'm honestly looking forward to the proof-based math courses. Yeah. Do look forward to it. Nema says, I'm afraid you'll be choked by AI courses. I guess they're teaching a lot of AI at undergrad level at the moment. I would not, yeah. I've not kept touch with how that's going, but I would imagine they're teaching a lot of it. That is probably true. Hopefully you won't be forced. I guess depending on your country, you might not be forced to take them. You can choose, right? Choose what courses you take, maybe. But I guess if you're applying to a CS program in your 30s, you're probably not in the US, which means you might not get to choose which courses you do in the same way. In the US, I understand you get to choose everything, more or less, but well, there are prerequisites, but definitely in the UK, like you barely get to choose anything, in my experience. You know, in theory, once I know all this math, I'm going to be able to go, I need to be able to learn machine learning properly. Obviously, I know it's the complete wrong type of maths, but just kind of bugs me that I don't actually know machine learning that well, because you know we're using it all the time. Feels kind of a bit dishonest intellectually to not know the backing for it. Like I feel like there should be like a version of like you know, that thing, every man should be able to like put up a tent, start a fire, sort out the horse's hooves, that type of thing. But for like, you know, you should be able to recognize the handwritten digits. You should be able to do that sort of thing. Leaf says the only AI related course is a single machine learning elective in the 3rd year. Nice. Machine learning, cool though. I've been teaching a bit of. I think occasionally, very occasionally, my students from real life drop in here, and they will know that I teach a lot of AI at the moment, and it's important to know that stuff, of course, and to software engineers, I should say. And I do a whole bit when I'm teaching about Deep Blue, and I show an image of the Deep Blue rematch. And the cool thing about Deep Blue, or the point that I make with Deep Blue, because I'm basically trying, what I'm trying to teach at that point is what's the difference between machine learning and artificial intelligence. Somebody made the point to me, a colleague made the point to me recently, that machine learning is a kind of artificial intelligence. And I guess that is also true. But my point in this session is I'm trying to say that machine learning is one way that you can get artificial intelligence. It's one mechanism for producing an AI system. And that AI is quite a vague term that's been used for all kinds of different things at all different times in history. And does anyone actually in the chat, does anyone have what's your favorite definition for the term AI? I'm actually really curious. What definition do you have for AI? Bonus points, by which I mean any points at all, if you can define AI without using the terms artificial or intelligence. That's the challenge. I have my own. I'll tell you afterwards. Leaf says, honestly, half the reason I applied for uni was I wanted to take a break from the gestures at the world. Yeah. There is probably no better time to take a break of about 5 years, like hone your skills and get ready. I mean, not everyone can do that, obviously, but Inner Climbot says, I would define AGI as a system that is capable of incorporating new information and adapting to new circumstances. Yeah. What about AI? AI is a much broader term, and I wouldn't want to go there. Yeah, fair. Nimbus is a neural network. I don't know if you mean that as a definition of AI, but we'll talk about that more in a moment. I think it's I think it's an interesting challenge to try to define terms, because not to get back into we're not going to get back into all that, but obviously we do get around in the world using words, and it's interesting to try to think about what gets applied to what. Yeah, and a Climbot says, definitely not. A single neural network doesn't achieve much. Yeah, wouldn't call an LLM intelligent. Would you call it AI, though? Wow, we're saying LLMs are not AI. Oh, how interesting. How interesting. Okay, anyone got anything else on AI? Anyone want to define AI? Like, to you, for example, Deep Blue, the chess computer that beat Garry Kasparov, the top human chess player of the time, is that AI to you now? Would you consider that AI? That wasn't AI either. Oh, interesting. So interesting. I think before LLMs, if we asked any group of professionals, I think you'd get a very clear decision that systems like Deep Blue were AI. I think that would be very, very common. Not saying you have to agree with that. And obviously at the time, it was definitely considered AI. Regular expressions actually were considered AI, I think, at the start. I think they were. I'm not 100% sure on that. And a Climbot says, I think the answer depends more on marketing now. It doesn't any intellectual rigor. Yeah, I agree. I agree. So I'll tell you my definition. Um, we have to define intelligence first, I think. Yeah. Very unfortunate thing about vocabulary is we don't have to define intelligence at all to say what to describe something as AI. Although it would be nice if we did have to, in a way. Um, so my definition of AI is um, anything that the speaker, the user of the term AI, would struggle to imagine how you could write an algorithm to perform that task. That's my definition. And we tend to use the term, I think, this is my take. I think we tend to use the term AI, and groups of people tend to use the term AI to refer to things that you would struggle to imagine a flowchart, a set of rules, a logic, an algorithm, a process, a rigorous process that you could use to perform that task. So, addition, not AI. You can imagine a set of a process to do that. Even something like calculating a credit score, something which might have been considered AI before. It's like, okay, well, now we've all got, well, don't all have, but many of us have these, apps that tell us what's on the credit score, and it's like, what goes into it. It's like, okay, probably, you pay back your bills, you get an extra point. You have a mortgage, you get an extra point. You don't pay back your bills, you like takes back something. You can just kind of imagine how something would be done with that. Generating an image from a text prompt, no idea. Not in a million years could I write an algorithm to go from one to the other. Like, I just couldn't imagine how I could possibly do that. Chess game, kind of depends. I think with AI, if you're a software engineer, or you're used to software in some way, or you have like a certain training, things like a chess program, like with Deep Blue, if you know about Deep Blue and you think, well, they generated positions, they had a way to evaluate positions, whether they were good or bad. Probably with enough time, I could imagine that there would be an algorithm I could use combined with big search computers or small search computers that I could use to like play chess at a roughly Deep Blue level. So, that's probably like not really AI to me. So that, because I can kind of imagine it. Whereas to somebody else, definitely someone like 50 years ago or however long Deep Blue was ago, probably, it would be considered, people couldn't really imagine how you could do that. And obviously the people who are speaking may call certain things AI that we wouldn't if they know way less about how computers work. Like if you are I don't have anything against CEOs as a group, but CEOs have a very particular job, and the job is not necessarily knowing how things work in depth. Like CEOs are, I'm not talking about like Jeff Bezos or anything, like ordinary CEOs, ordinary business people, like they're often not trying to know how things work in depth. It's just not, like, they do a job, but that is not their job. And so to them, if like they may just have a very surface level understanding of what these terms mean. And so if they are thinking, oh, I guess, kind of seems like AI to me, it's not like an easy if then, probably going to be AI. Seems like that. Let's call it AI. Yeah. So that's my definition. Doesn't come to anyway. So the point. Yeah. Anyway, so in the Kleinbot is saying, I generally avoid the term AI and use machine learned. Instead, it's more honest about what's happening. I think the intelligence part is ill-defined. So the reason that I talk about Deep Blue in my sessions is because Deep Blue was not machine learned. It did not do machine learning. They were using an expert system, and so they found I really should remember the name of the grandmaster they found to basically tell them all kinds of stuff about chess. At least I don't think they did machine learning. I'm pretty sure they didn't do machine learning. And they tried to encode all of the experts' knowledge in some system that could evaluate boards to see whether they're good or bad. And they tweaked this loads. And then they developed actually the big thing that made it possible was they developed custom hardware that could like churn through possessions, like for them incredibly fast. And so they combined their expert system with superhuman speed, basically superhuman generation and assessment, computing really, as in very fast computation, and then they had something which appeared to operate at a human level. So this is an AI which is not machine learning. They didn't go and try to learn from data, or at least the algorithm did not learn anything from data. They tried to inject human intelligence. They tried to encode what humans knew about chess into a program and then combine this with the thing computers are very good at, which is a very interesting way of coming up with AI, but not machine learning. Anyway, so I use this to try to tell people, like, okay, what is machine learning? It's not just AI. It's a particular way of like producing things we might call AI, or producing nothing if it doesn't work. In a client bottle, you'd probably say that sounds like a parameterized algorithm. Yeah, makes sense. Yeah. True random number generator is AI too then. Yeah, good challenge. Yeah, I guess there is something about AI which is, it's not purely things we couldn't imagine an algorithm for, although it must be maybe it's a subset of that. But yeah, you're right. There could be plenty of things in that category which we wouldn't call AI because they're a bit esoteric or, yeah, it's interesting. Interesting point. Thank you. Yeah, it's an interesting point. Atom Fighter's saying Atom Fighter's going to drop the chest workout program. I do have some DOMs today from my chest workout program yesterday, which was my coach telling me to do press ups, burpees, and lunges till 12 minutes were up, which was not very fun, but quite worthwhile. Anyway, a while ago, Happy Nora, I think, claimed to have solved this problem, maybe. So let's try and see if we can catch up. Yeah, it was pretty unpleasant, but it was a good workout. Okay, 10. Suppose A and B are integers. If A divides B, then A divides. Eesh. A divides this horrendous thing. Three B cubed minus B squared plus 5B. Wow. Happy Nora's keeping your cards close to your chest. Oh, by the way, I got the 60 kilogram bench press recently. I know everyone's been very excited to follow my progress on the bench press, but sorry I kept you waiting. But yeah, I hit the 60 kilogram bench press. Rapturous applause, maybe? Yeah. It's good for me. Okay, all right. So, with this one, yeah. Okay, with this one, we're going to have this thing over here. Oh yeah, sorry. A divides this. Yeah. Okay, so I guess that's 2 of that. We're going to say 2. 3B cubed minus b squared plus 5b equals AC, where C is in the integers. Okay, and then we've also got B equals AD, again where D is in the integers. And we want to show that if A divides B as true, then A divides that whole horrible thing is also true. All right. Happy Nora's dropping the answer. Fortunately, I can't read. Okay, so what am I even trying to do? Like, so far I've sort of progressed sometimes by just trying to make this look like this. I guess we could rearrange this, maybe. Or I guess another way of looking... Could we go the other way round? I mean, I don't even know if you can go in reverse with this. Like, you could try and make this look like this. I guess in principle, it's the same. It's the same operation. Maybe we could try that. People are saying factor out B. That's what people are saying. You could try and factor out B, and then you make that look like this, maybe. If we did that, we'd end up with 2b, 3b squared minus b plus 5 equals AC. That 5 looks really bad. Oh. Missed that too. And where did that 2 come from? Where did that 2 come from? Where did I put that? It came from nowhere. Just made it up. Why did I do that? Unless I did put it there for some reason. I don't think I did. Can't see where it could have come from. Okay, so we factor out B and then we get B does not equal A. No, I don't know what I'm doing. I don't know what I'm doing, really. Okay. What's the question again? Suppose that A and B are integers. If A divides B, then A divides this other big thing. Malloran says it's just 3B, yeah, etc. ACK or ACK. Oh no, ACK where K equals... Right, so you're kind of discarding the... Oh right, so you're adding something on. Right. No, I'm not following. Okay, back to trying to find the track. Suppose A and B are integers. If A divides B, then A divides this other thing. So one way we could do this is by taking this and then trying to put it in. Thanks, Malloran. Malloran is taking B equals AD and multiplying that thing on both sides. Okay, let's try that. I'm starting to feel that this is not going to make any sense. It really is true that the solutions make no sense until you understand what you're supposed to be doing. Yeah, yeah. Okay. Right. Let me think about this. So we've got this. Come on. Fat. We've got this. We've got A equals B, therefore B equals AD. And we're trying to show that if this is true, then also A divides 3B cubed minus B squared plus 5B, which by definition means that AC equals 3B cubed minus B squared plus 5B. Now, how do we prove this? We could show that they're equivalent by trying to transform one into the other. We could try to put them in this form and try to find out what D is. In which case we need to have a B equals A and then something. But we haven't involved this yet. Or we could we could rearrange, we could work with this to try to find out what D is. Or we could work with this. We could work with this to try to find out what C is. I think this is the way round we should be doing it, right? If we want to show that if this is true, then this is true. So if we do this and we go AC is equal to 3 AD cubed minus AD squared plus 5 AD We could take an A out of this, maybe? So AD cubed is going to be... I forget the rule with that. I guess you can probably do this. It's probably in the other order, right? In which case C becomes... C becomes this. And is that us done, maybe? We go through this again. If A divides B, then we've got this to use, which is we have used it. Then A divides also this, which kind of, you know, would make sense anyway, because, you know, intuitively this is all multiplications and additions of B. So, and subtractions. In which case there's something in which case this is true. There exists some C that will make all this add up, and the C is going to be this, and the D comes from this. The A we've got here. There's no B involved, which kind of troubles me. But I guess we could substitute it back into this if we wanted to. Doesn't look very nice. All right, what does chat think? Am I totally misguided? Okay. Correct. People are saying factoring out B proves it on the spot, but I don't quite see it. I'm sure you're right. But I mean, the issue is, it's not that I don't believe you, I just don't understand it. We factor out B. Okay, so I'm going to factor out B, and then I'm going to say, I'm going to be very bratty about it. Okay. All right, so bear in mind, somebody said on the spot. Okay. I don't feel like I've proven anything. Substitute it for AD. You're saying substitute. But we don't know the definition of D, right? So how can we substitute? Oh, you mean so you're trying to rearrange it so it's B equals, is that right? Because we can't substitute AC into anything because we don't have that anywhere else. If we change this to B equals, we get like AC over some horrendous thing, which doesn't seem like it would help very much and hasn't come up in anywhere. So I must be wrong about that. You write AC equals, oh, you mean, oh, I see. Substitute into this. I see. Mm-mm-mm. So you write AC equals AD. All right, so we got this. AC equals AD brackets 3b squared minus b plus 5. So we get that. D is defined. Yeah, I know it must be I know it must be frustrating watching, but it's not becoming any clearer to me. Yeah, I see all the steps, but I don't see what it's I don't see how we're getting from here to we're supposed to end up with something that looks like this in the end, right? Or something like that. And we do have something which looks a little similar. Divide by A both sides, okay. This is C. Right, so this is the other way we're looking. This is a way of finding C. And because we've got C, we can now say we've got C. Right. Inner climb bottle is diagnosing. The confusion is coming because you've already decided that C is what you're looking for. You need to look at B, not the polynomial thing. Okay, let me run this through again. Suppose A and B are integers. If A divides B, then A divides this other thing. For this to be true, there needs to be a C that we can multiply by A that will get all that nonsense. So we need to find that C. We can't make it out of nowhere, but we can make it out of the thing we're given. A divides B. A divides B gives us B equals AD. And we can get that through these two different routes. We can get it either by substituting every B in, or we can extract B, and then we can substitute only the first B, which we do here with the option in the chat. If we do that, then we end up with a definition for C, which we can then say is the integer. We know this is an integer because it's, uses all the correct operations. Okay, I think it makes sense. Thank you for stepping it through with me, Namir and others. I appreciate it. I guess the impulse to not do any of this, I guess, is because all of this is like work, right? Whereas if we extract the B and then substitute only this B in, we don't have to do so much work. And I also, yeah. Yeah, and then if we wanted to be 100% sure, as you're saying, Namer, we could work it out by getting definitions for A and C, putting them all in here and then rearranging, I guess. Okay. I don't think I'm going to do that, but we could do that. Okay, exciting. Somebody described that as a fun problem. I suppose that is fun. What time are we? We're on 4 hours. Let me just... Wow. Twitch is telling me I'm online. Okay. Right. I'm going to take another short break. And I'm going to say hello to my friend is actually in the other room right now. And I'm being very antisocial. I'm going to take a short break. I'm going to get myself another dash water. Fuel me through. And then we're going to try 11. And then we're going to try 12. We might try. And I just paused before I meant to. See you in a few minutes. Oh, also, Esther Destroyer, hello. I didn't see you there. How are you doing? Um, I was going to say I'll be away, so I might not hear your message, but I'll see it when I come back. Hello, everyone. Leaf is fantasizing about hosting a girls' night where we all just do math proofs together. That's quite a fantasy. Dan Gott says, sorry, I only just joined, but for 10. Wouldn't it be easier to show the general case holds for any A, B, and C, where A divides B and C is a composition of B under... Yeah, I mean, you could be right. Probably important context is I have a very limited toolkit, and I don't have many of the... probably you're right, but if I had those tools in my toolkit, I would be able to do that. Anyway, so I've got my new dash water. It's the 5-hour energy drink of this stream. And I've got something very exciting also. You see, lately there's been a month called Pride, and there's a bakery near me. The bakery has made certain items for this month. One of them is what I'm calling the viral Pride cake pot. It looks like this. Don't you think? Don't you think that's like it's gone instead of my head? The background has been removed. I'm the background. Look at that. Anyway, inside it is cake. You think that's cool? I thought I'd show you. I'd show you it because one was bought for me today. And it's viral, so you know. Anyway, very nice. It's like birthday cake. Okay, that interlude aside. Wait, I've still got my Sports Direct mug here. That viral interlude aside, I mean, Inner Climbot was saying, girls' night would be too exclusive for me. Girls' night, any night that involves doing proofs, plural, is too exclusive for me. Oh, I'm going to be so happy when I'm really good at this. That I'm just reminding myself that. I'm going to be so happy. I'm going to be like, it's going to feel great. Okay, 11. Now, 11, already good because Richard's going to help me with this one to work out if I've done it right. Happy Neoino. Yeah. I don't even know how to pronounce my own username. Neoino. I'll be very happy. I'll change my username. I won't change my username. It's Brand Dilution. I already should be called K-Lac, really, because I join people's channels. It's kind of cool. Right? I join people's channels as an audience member, and then later, the next time I join, they're like, "Wait, I know your videos." So it's not a very good username. Millerin says, a lot of these early exercises are just writing down the definition and doing some light algebra until the answer falls out. That could be true. But you have to do the right algebra. And I barely know what I'm supposed to be aiming for at this point. I know it may seem very simple. It will become simple to me. My username on YouTube is still new in it. That's true. That's true, actually. But who pays attention to the usernames anyway? Okay, 11. Suppose A, B, C, and D are all in the integers. If A divides B and C divides D, C divides D, then AC divides BD. So A divides B and And we just write and. Take someone's advice. A divides B and C divides D. And we're kind of going to go for AC divides BD. Most stuff later is proof by induction. Maybe, actually. Well, I actually don't know. I think, you know, weirdly enough, in this book, proof by induction is actually optional. I guess because proof by induction is like it's a recursive method, right? You need to be able to prove the first case and the n+1 case. So you kind of need to be able to do quite a lot of proof already. This story says, I'm somehow waking up drenched in sweat, even with AC on. If I get a cotton bed sheet to cover myself, yeah. It's hot. What's the temperature where you are, Ice Destroyer? Temperature update. In the clan bottle says, induction doesn't come up all that often. Direct proof or contradiction is far more common, in my experience. And this is said as somebody who spent a lot of time writing out transfinite inductions in their thesis. And Malone says, induction comes up a lot specifically in CS, though. That was what I was wondering, actually. I guess it's pretty important in CS. Nope. Okay. So we can then substitute in. Maybe. Or maybe not. Maybe this doesn't help at all. Well, I guess if we can then say this. So we then have is this enough? Does this count? Does this count as a proof at all? Kind of feels like I followed the steps. Yeah, so we're saying the proposition is, suppose such and such. If A divides B and C divides D, then AC divides BD. If that was true, we would have this thing. We'd be able to say there's a BD, or there's a CZ, there's a AC that you can multiply some integer. I guess we should do this. Probably do that better. What am I doing? Get this right. Come on. Come on. How's this even supposed to work? There we go. There's some integer you can multiply AC by to get BD. We can find that integer through using the definitions of B and D given earlier, or we have to, in fact. So we substitute those in to get the Z, which is going to be XY, and then BD equals, yeah, and so then we've got the thing of the right structure, and we know that the Z, or Z if you prefer, is going to be XY. Okay, what does Richard say? Let's test ourselves against Richard's logic. When I say ourselves, I mean me. Okay, 11. Suppose the thing, yeah, definition divisibility, yep. Since B equals AX, we can multiply one side of D equals CY by B. Since B equals AX, we can multiply one side of D equals CY by B and the other by AX. Wow, you can do that? I guess you can. Crazy, I never did that operation before. Okay, this gives BD equals AXCY, or BD equals ACXY. Since XY is in the integers, the definition of divisibility applied to BD equals ACXY equals, or gives, AC divides BD. Now, I did get, I think, the same result through a different means, which means it's a different result. So I think I still did all right, but he just thought to do something different. He thought to get it a different way. Interesting. Doesn't tell me anything about whether my method is right or not, but I think it doesn't. It's hard to imagine I could have gone that wrong. Okay. Inner Kleinbottle observes, the way you've written it almost feels like you're assuming that it has the form ACZ. In reality, you're doing the computation on the left to arrive at the formulation on the right. I saw this a lot with my students when I was teaching. So what you're saying in a Kleinbottle makes sense, because that is what I'm thinking. That's my pure process. All I've learned about proofs at the moment with any solidity, and it's not really very much solidity, is it seems like proving is the process of you take some notation which is not very useful on its own. You translate it into some algebraic form like this, and then you have a picture on your wall. The picture on your wall says, you put this on your wall, it's in oil paints or whatever, and you're like, right, and also this, and also this, joined up. You put this on your wall and you say, all right, I got to end up with this. I got to get this somehow. And I've got this thing itself somehow, maybe, or maybe not. Because, I mean, these are things we know to be proven already. So I think if there was an indeterminate statement, I think my logic would totally fall apart. Let's say we want this. We've got something. We've got stuff. We probably have to use this in some way. It does seem obvious to me, although not obvious in practice, that if I don't use these things, I can't have proven anything. So I will need to use these somehow, though I don't know exactly if I have to use all of them or not, or if I didn't, what would happen if I didn't use them, although I assume it would be bad. And then I kind of muddle everything around until it looks like this, and hopefully also satisfies whatever additional rules it comes with. And if it ends up looking like this and it satisfies this rule somehow, probably I win. Something like that. I don't know whether this is right or wrong at the moment. This is my novice understanding. And InclineBot is indicating that, yeah, InclineBot says, yeah, it's fine to set out what you aim to show, but you should work with one set at a time. Spell out what you're doing to coerce it into the thing you're saying it should look like. Yes, I'm being very terse in my notation, and the only reason for that is laziness. Yeah, I'm under no illusions that it's good, other than it's good for now, but I will need to improve it, which I'll be improving my process with. Yeah, writing it out. Yeah. I mean, one way you can think about it is, if this was my homework, then it would make no sense. But I'm also talking at the same time, so you can substitute a little bit of my words talking in for that in this case. But basically the only reason I'm not writing longer is because it takes me ages to handwrite and type all this stuff out. But I appreciate that it's not that will need to change. Yeah, no, I appreciate that. I'm in a climb bottle, thank you. Did I like maths when I was at school? Asked Naymir. It went in and out. Yeah. It went in and out for sure. I never hated it. I don't think I liked a lot of the. It's such a classic thing that people say, oh, I didn't like the way they taught it, which is to say, the subject was very interesting, but the courses were not so interesting. And I struggled to apply myself, I think, is probably sum up my experience at school. They were very, with my school, they were very, my teachers are very keen on me making notes in the what are they even called, lessons, and I couldn't write and think at the same time very easily, so I never did. And they weren't very happy with that. Okay, this one, I promise you all, this one I'm going to write it out. I'm writing properly this one. Okay. Just to show you. I'm writing it just how Richard taught me to. But I'm actually going to reset this first. Why am I getting paused right up there? Okay. If x is in the... Oh, we're on the real numbers. Come on. If x is in the real numbers... Oh, we got kind of an interesting one here. And... And it's... Come on. Oh my gosh. Come on. Wow, okay. My laptop's getting real upset at me now. Then we've got 4 over x by 4 minus x is greater than or equal to 1. Okay. Malone says, I have to say, I did not expect to enjoy watching someone work through a textbook as much as I do. Props to you. Well, I didn't expect you to enjoy it that much either. But I'm glad you do. I really do think I really do think it's going to get a lot more exciting when we're back in the art of computer programming. I really do think that. It's already kind of exciting. It's exciting to me. Okay, so that's the proposition. I need to highlight this. I keep losing it on my page. There we go. All right. Now we write this. We do this. My brain seems to think that a long-tailed P is a capital letter P, but it's not. That's not how P works. It should work like this. Right. Now, I don't know how to prove it, so I can't fill out the rest yet. So I'm gonna scribble, and then I'm gonna go back and make it make sense. Oh, sorry, just slamming the microphone there. Oh wait, I just got your joke, Happy Nora. That's true. I missed it. I didn't get it. I think this is a case where I may need to review earlier material. Or I may need to... I may or may not need to, actually. If it's a real number, I can't enumerate anything. It's not like I can check all the cases. That's the only thing I didn't really go study thoroughly or at all. But I'm so rusty on inequalities. Is there anything that looks kind of similar? Oh, similar. Okay, there's something here. All right, let's read through this one. Let x and y be positive numbers. If x is less than or equal to y, then root x is less than or equal to root y. Proof. Suppose x is less than or equal to y. Okay, so it's an if then, so we start off with that. Subtracting y from both sides gives x minus y is less than or equal to 0. Yeah, this can be written as that. Factor this is a difference of 2 squares to get. Right, okay, so basically, yeah, fine. So I think the basic approach here, right, is to take this thing on the if, take the given part and transform it into the then part. Okay. Now, one thing I do remember about things that look like this, but I don't remember much about it, is if you perform certain operations, you need to flip this around. And I'm definitely gonna make a mistake with that if I have to do that, because I don't remember anything about what the rules are. So I'm just gonna have to derive it from my own brain. Okay, so we have like kind of two... We can't really operate with this, I don't think. So, I mean, I can't anyway. So we could break it up. In fact, let's just do this in different color so we're clear it's just working. Prude. Oh yeah, I guess it does look like a prude. There you go. Okay, so we got that. Does that help me at all? No. Well, we could try putting an X on the top. Sorry, a 4 on the top. We could say... Now, I don't know if this is right. Probably not. So, what is this? Wait, can you even do that? What do I even do there? Just put a 4 on the top. What does that mean? Divide? No, I'm doing something. I'm just making up mathematics. What am I doing? You can't just put something on the top. That doesn't make any sense. Okay, we could. If we wanted to change this into this, what would we have to do? Can you even do that? There's like a weird power you can do, but that doesn't seem right. I guess you could do this. You could do that. I don't know why you would want to. It doesn't seem very right. Okay. Well, we could divide by 4. I'm fairly sure this will still hold. If we did this, dividing by 4 shouldn't change the inequality. Why is X on top all of a sudden? Why not? X is on top because I'm dividing by 4 just to see if I can get anywhere closer to what I'm supposed to be going for. Doesn't seem very convincing. We could then divide by 1. We could I swear there's something you can do to swap these over. You don't have to go from left expression to right expression. Did I solve this in a non-proof way on the other screen? No. And I've never solved this. This is unsolved by me. I guess we could try looking at it a bit first before we try and prove anything. So, like, let's try 2. So I don't forget. Okay. Well, that works out. What about with a different number? That's 1.3, right? So that's greater than or equal to 1. If x was 4, then we'd have, oh no, it can't be exactly 4. Then we'd be dividing by 0. If it was like 3.9, a bunch of 9s or whatever, then we'd end up with something very small. Probably. Yeah. Maybe. 4 breaks math, true. What would this be actually? I'm going to calculate this one. 4 divided by 3.999 times 4 minus 3.999. It's like some high number. Right, because the smaller this part gets, the bigger this is going to get. Right, and then if this is low, like let's say it's 0.1, we end up with 0.1, 0.1. That's also going to end up kind of small, right? Yeah, the smaller it gets, the smaller it gets. And then we're dividing by something very small, so we end up with a kind of a big number. So 2 ends up being the kind of, it's kind of a funny shaped thing, right? Is it kind of like, is it like a bit like this? Not obviously like that, but is it like something like that? Guess it must. No, it's not. It's other way. Yeah. And then it's bigger this way. Kind of funny. Let me plot that actually. I just want to make sure I'm not massively wrong about that. Y equals 4 divided by x times 4 minus x. Whoa, it looks wild. Okay, it looks weird. It looks, I'll tell you what it looks like. I'll draw it for you. So we've got Yeah, we've got like, we got this, then it goes like this between 0 and 2, I think. No, 0 and 4. Sorry, I lied. And then elsewhere, it does like this. No, it doesn't do like that. It does like that, and it does like that. Oh my gosh, come on. Become a better programmer, okay? Looks like that. Okay, interesting. And where does it? Yeah. So this point, this is like 1 here. That's 1. So we're kind of like checking. We're trying to prove in this interval 0. Actually, may change colors. Between this interval 0 and 4, does this kind of line here ever get breached? Okay, they're saying go from the right one to the left one. And I don't know if my ability to work with inequalities is actually good enough to do that. Let's see. You know, this was actually what this type of problem contains a bunch of things that tripped me up some weeks ago. Okay, so we can subtract from both sides. We could do that. Let's get rid of this. We don't need that. We could subtract from both sides, in which case we'd end up with... Can't I draw a straight line? You know, I don't think my algebra is up to this. I really don't. I think I'm probably not going to do this. I mean, the only thing I can think to... I mean, this is already a problem. Because how are we going to make that from a equal to a less than, or you know, yeah, or a greater than? Although maybe I'm just totally wrong about all this. It's only X we need to. Only X we need to care about. So we could just try and get rid of everything that's not X. Maybe. Um. Is it then accurate to say? Imagine it was. I definitely need to revise this. Probably do an auxiliary inequalities stream or something just to drill that. Now we could extract the X from this, maybe? No, that doesn't work. Put in the X. They're saying we need to flip the sign here. You mean this one, Naimir? So like this? All right, so something about this change meant we had to flip the sign. Mental note to look that up. I don't know, I've forgotten all the rules about when you flip the sign. Right. 1 over x is less than 1 over y, then x is greater than y. I see. Don't lose the right. We still need the equal. Damn, I was really hoping that would go away. Okay. This doesn't change anything. Do I know how to solve a quadratic inequality? No. You have to find the roots. Oh. It's not looking good for me on this problem. Oh, there's a whole method from here? Oh my gosh. Okay, there's a whole method. They're saying there's a method. Alright, I guess there's no rules. I can't look anything up. How to solve quadratic. Alright, alright. There better be some images. Uh-oh, there's a YouTube video. Uh-oh. Oh, right. Okay, wait. So we stay with this form, I guess. Fine. Okay, we stay with this form. No, we don't. We have this. No, we do stay with this form. But this is going to be like x plus 0 or whatever. Okay, there's a whole method. There's a whole method about it. Hmm. All right, there's a whole method I don't remember. Let's do 13. First time chatter coming in with the idea. Oh my gosh. Come on. I'm on some sort of revision website. It's not good. It's not good. Really makes you remember why we invented AI. Okay, great. Okay, all right, all right. They're saying graph it. They're saying graph it and everything. Oh my gosh. Wow, okay. What a mess. What a mess. Okay. All right. Right. So, fine. Here's what I'm hearing. Let me tell you what I'm they're saying we messed something up. Did we mess something up? So we could do... Right. So we could do... All right, I'm going to try something. Chances are it's not going to go anywhere. But we'll find out. And we'll see. Maybe we'll get close to something. They're saying you want this. They're saying you want a 0 in there. That's what the internet's saying. Now, if we have this, we've got minus x squared plus 4x. Doesn't look good, does it? Doesn't look great. Is this a bad idea? Is this a bad idea? It's feeling like a bad idea. Pretty sure that doesn't work. Pretty sure that doesn't work at all. Because that would need to be either 1 or 4. I've already graphed it. I know the I can see the graph. I mean, the graph is not so complicated. It looks like this. The graph kind of proves the whole thing, but it doesn't help me get very much further. Okay, so this has got to be like that, right? But one of these has got to be minus. No. Yeah, one of these got to be minus, and that doesn't work, right? Because we've got to get plus 4. I guess actually no. Maybe it could work. Where did that 4 on the right-hand side come from? It should be 1. Oh, it came from here. Because I wanted to get rid of this thing. I wanted to get rid of this 4 on the top. I don't know why. I just thought it'd be problematic. Name is saying we can't do that. Okay. What can we do? Well, there's only 2 choices, so let's find out. No, it doesn't work. Doesn't work at all. Doesn't work at all. No, nothing. Nothing at all. No, nowhere. Nowhere. The answer is know how to do... The proof is know how to do all this. And I don't know how to do all that. The proof involves knowing that. Knowing how to deal with all this stuff. And I just don't know how to do it. Hello, it's Really Ren. How you doing? It is hot. How hot is it where you are, It's Really Ren? I believe you, Miller, and I believe you did provide a proof. Peaked 30, wow. 30's pretty hot. 30's pretty hot. Okay, 12. We're gonna leave. I'm gonna leave 12. I'll leave 12 for me anyway. You're welcome in the chat to puzzle over it. Are we gonna get anything? I think I probably just need to know a bit more algebra to solve these ones from here on. Yeah. Yeah, so these I'm going to come back to. Hopefully they will become easier. I may know how to complete the square, but I don't have great facility with it. I don't have enough facility to work out if I was going in the right direction or not. Yeah, I think that's just something I need to revise to get through these ones. What comes after this? Oh yeah. Was it Malone? You were talking about this earlier? Or maybe I think I'm gonna go back and I'm gonna look at the cases thing, because I definitely skipped over that last time. I'm gonna inject a bit of that into my brain. I think I'm actually just gonna go through some of these proofs. Right, so what looks weird? What looks a bit challenging? This one looks okay. This one's in the natural numbers. That's all right, but it does have a little bit of an unusual function, but I don't think that's that upsetting. Yeah, and then we're getting to these. Okay. All right, I'm going to just puzzle through this one, get a bit more into my brain. Let x and y be positive numbers. If x is less than or equal to y, then root x is less than or equal to root y. Suppose x is less than or equal to y. Subtracting y from both sides gives x minus y is less than or equal to 0. This can be written as root x squared minus root y squared is less than or equal to 0. Okay, fine. Factor this as a difference of 2 squares to get yep, okay. So he's taking a bunch of interesting steps there. Oh, we're on dark mode now. I need to stop dark mode turning on. There we go. Fine, okay. Dividing both sides by the positive number root x plus root y produces root x minus root y is less than or equal to 0. Adding root y to both sides gives root x less than or equal to root y. So he's sort of, right, this is what he's trying to prove. He supposes this. He puts it into this form because he kind of wants to get here, it seems to me. And he does that through creating a difference of two squares and then taking that kind of here then he gets rid of this part of it. It's important that it's the positive number because otherwise I guess the inequality would have to change. Is that assured to be a positive number? I suppose it must be, or you wouldn't do it, but actually square root is... All right, let's ignore that for now. Then we get that. Then we get that. This proposition tells us that whenever x is less than or equal to y, we can take the square root of both sides and be assured that the root of x is less than or equal to the root of y. This can be useful as we see in the next problem. That proposition will concern the expression 2 root xy is less than or equal to x plus y. Notice when you substitute random positive values for the variables, this expression is true. For example, yeah. Is it true that this expression works for any positive x and y? How can we prove it? To see how, let's first cast this into the form of a conditional statement. If x and y are positive real numbers, then this is satisfied. The proof begins with the assumption that x and y are positive and ends with this. In mapping out a strategy, it can be helpful to work backwards, working from the end thing to something that is obviously true. Then the steps can be reversed in the proof. Right. In this case, squaring both sides of this expression gives us this. Then we subtract 4xy from both sides to get this. And then we get this. And this line is clearly true, since the square of x minus y cannot be negative. This gives us a strategy for the proof which follows. Here's the proposition. We get the proof. Observe that. Right, and then he reverses it. He reverses the process basically in the proof. So he's going from this. He pulls this out of thin air, but really he got it through a reverse process. Fine. Notice in the last step of the proof we took the square root of both sides of such and such and got, yeah, the fact that this did not reverse the symbol and the fact that this did not reverse the symbol followed from our previous proposition. This is an important point. Often the proof of propositional theorem uses another propositional theorem that has already been proved. Okay, interesting. It is 10 p.m. actually. It's a climb bot. That's a good point. This explanation is before question 12. It's the chapter that includes question 12. Question 12 it comes at the is part of the exercises for this chapter. I'm reading backwards to try to inject a little bit more into my brain. All right, do I want to read the using cases thing? The using, yeah. Okay, let's read it anyway. In proving a statement is true, we sometimes have to examine multiple cases before showing the statement is true in all possible scenarios. Oh, you know, that's what I missed. We need to prove it for all. We need to go through all the real numbers between 0 and 4. And prove them all individually. It might take a while. No, it won't help with our question 12, but it's interesting anyway. Our examples will concern the expression this. Here is a table showing its value for various integers of n. Notice that it's a multiple of 4 in every line, which it is. Is 1 plus whatever always a multiple of 4? We prove the answer is yes in our next example. That's the question. Notice, however, that the expression behaves differently depending on whether n is even or odd. For in the first case and the second, So in first case and second. Thus, the proof must examine these two possibilities separately. Okay, interesting. Right, so we got two cases, and then he's performing the work for each case. And then he changes the question. Let's examine the flip side of the question. We just proved that this expression is always a multiple of 4, but can we get every multiple of 4 this way? The following proposition and proof give an affirmative answer. Every multiple of 4 equals such and such. Every multiple of 4 equals this expression for some n in the natural numbers. Proof. A conditional form, the proposition is as follows. If k is a multiple of 4, then there is an n in the natural numbers for which this expression equals k. What follows is a proof of this conditional statement. Suppose k is a multiple of 4. That means k equals 4a for some integer a. We must produce an n in the natural numbers for which this expression is k. This is done by cases, depending on whether a is 0, positive, or negative. Right, okay. Suppose a equals 0, and then we do this. Suppose, okay. So he's just looking at the cases above, below, and equal to 0. Fine. And then this Okay, interesting. Interesting. Okay. People are hating manipulating both sides of an expression. That's interesting. I'll think about that. All right. It is indeed 10 p.m. It's actually 10:13 p.m. And we're going to call it there. The main reason isn't that it's 10 p.m. The main reason is because my house is now free enough for me to make dinner. Ah, so good. Thanks for hanging out. I forgot it was even Sunday. Will I be streaming this Thursday again, like normal? Yes, I will. I'll be back on Thursday. Thanks for hanging out, everyone. It was another difficult challenge today for me. So thanks for sticking with the program. I'm afraid to say, we're not going to be raiding Stephen Wolfram today. Very sad, I know. He's not streaming right now. Thank you, It's Really Ren. Thanks, In a Klein Bottle. Thanks also, Naimir, for all the support throughout. If you're still here, I think you are. And thanks, Maloran, also for hanging out from the game stream. I think I've been watching too many non-English language streams because I'm getting loads of my raid screen is mostly non-English channels now, but although maybe that's because it's 10 p.m. in the UK. Okay. Oh, well, we're not, yeah. There are some wild VTubers out there these days. There are some wild VTubers. Nothing against VTubers, but some of those avatars, you see them and you can't unsee them, you know? This person have... I'm just seeing someone who has Elon Musk's profile, a photo of Elon Musk as the profile photo. Okay. All right. Here we are. We're going. Back in the day, I used to be a Ruby engineer, if you can believe it. Not really anymore. Nothing against it. I'm just not. But somebody else is. So we're going to go hang out. Hope you have a good rest of your day. And I will see you potentially on Thursday. So maybe see you again then. I'm looking over there, over the chat, just hello. But you can't, the chat, you don't know you're in the bottom right-hand corner of my screen. But you are. Oh, and thanks for the sub, Alex, because thank you very much. And thank you to the camera. Let's go.